across the vast and sprawling savannas of Africa, where the golden grasses sway in the wind and the horizon seems endless, and through the dense, lush forests of Asia, where the canopy forms a green ceiling above, majestic elephants roam freely, embodying the spirit of the wild. These intelligent giants, with their expressive eyes and intricate social structures, possess a secret language, a world of communication that goes far beyond our human perception. Elephants communicate with infrasound, producing sounds that are too low for the human ear to detect. These deep, resonant rumbles are not just random noises. They are a sophisticated form of communication. These infrasound waves can travel for miles, cutting through the dense forest foliage or the open savanna, connecting herds that are separated by great distances and conveying vital information about their environment and each other. But their communication extends beyond their ears. Elephants have an extraordinary ability to sense these low-frequency vibrations through their feet, a phenomenon that is as fascinating as it is mysterious. Astonishingly, elephants can detect these vibrations through the sensitive pads of their feet, feeling the messages carried on the very ground they walk upon. This seismic sense allows them to communicate over even greater distances than sound alone could achieve. This remarkable ability is crucial for their survival. It allows them to detect danger, such as the approach of predators or human threats, find mates during the breeding season, and maintain social bonds with other members of their herd, even when they are far apart. In this essay, we will delve into the fascinating world of elephant communication, exploring the science behind infrasound and how these low-frequency sounds are produced and received. We will examine the role of their feet as seismic sensors, understanding how these gentle giants use the ground beneath them as a medium for communication. Furthermore, we will discuss the implications of this unique form of communication for their survival in a world increasingly dominated by human activity. As human encroachment on their habitats continues, understanding how elephants communicate can help in developing strategies for their conservation. Join us as we uncover the secrets of these gentle giants, exploring their extraordinary ability to hear with their feet and the profound implications it has for their lives and our efforts to protect them. Through this journey, we hope to gain a deeper appreciation for these magnificent creatures and the complex, beautiful world they inhabit. The world is alive with sound, a symphony of vibrations constantly traveling through air, water, and even the solid earth beneath our feet. From the gentle rustling of leaves in a dense forest to the powerful roar of ocean waves crashing against the shore, sound is an integral part of our environment. It shapes our experiences, influences our emotions, and even affects our physical well-being. But beyond the sounds we can hear lies a hidden world, a realm of vibrations that our ears are not equipped to detect. This is the fascinating world of infrasound. While our ears are attuned to a specific range of frequencies, a hidden world of sound exists beyond our perception, the realm of infrasound. Infrasound is a type of sound wave that falls below the lower limit of human hearing, which is around 20 Hz. These low-frequency sounds are all around us, generated by natural phenomena such as earthquakes, volcanic eruptions, and even the wind. They can also be produced by man-made sources like explosions, machinery, and large-scale industrial processes. Infrasound refers to sound waves with frequencies below 20 Hz, the lower limit of human hearing. These sound waves have much longer wavelengths compared to the sounds we can hear, which allows them to travel great distances without losing much of their energy. This unique property makes infrasound particularly interesting for scientists and researchers who study natural events and animal behavior. These low-frequency sounds have extremely long wavelengths, allowing them to travel vast distances with minimal loss of energy. For example, the infrasound generated by a volcanic eruption can be detected thousands of miles away. This ability to travel long distances makes infrasound a valuable tool for monitoring natural disasters and understanding the dynamics of our planet. Think of dropping a pebble into a still pond. The ripples spread outward from the point of impact, traveling across the surface of the water. Similarly, infrasound waves propagate through the environment, spreading out from their source and carrying information over vast distances. This analogy helps us visualize how infrasound moves through different mediums, whether it's air, water, or solid ground. Infrasound acts in a similar way, propagating as waves of pressure that radiate through the environment. These waves can pass through obstacles that would block higher frequency sounds, making infrasound an effective means of communication for certain animals. For instance, elephants use infrasound to communicate over long distances, sending messages through the ground that can be detected by other elephants miles away. While we may not be able to hear these low-frequency vibrations, many animals, including elephants, have evolved to utilize this hidden channel of communication. Elephants can produce and detect infrasound, allowing them to stay in contact with each other across the vast expanses of their habitats. This ability is crucial for their social structure, helping them coordinate movements, find mates, and warn each other of potential dangers. The world of infrasound is a testament to the incredible diversity and complexity of life on Earth, revealing the hidden layers of communication that exist beyond our senses. Elephants are masters of infrasound, producing a variety of low-frequency calls that rumble through the landscape. These calls are not mere grunts or roars. They are complex vocalizations with distinct frequencies, durations, and patterns, each carrying specific information. Elephants produce these low-frequency sounds using their larynx, the same organ we use for speech. However, their vocal cords are much larger and looser than ours, allowing them to generate sounds far below our hearing range. These deep rumbles travel remarkably well through the ground and air, carrying for miles across the savanna or through dense forest. A mother elephant can keep track of her calf from a distance, or a bull can signal his presence to potential mates miles away. These infrasonic calls are essential for maintaining social cohesion, especially for elephants living in habitats where visual contact is limited. Elephants possess an extraordinary ability to hear these infrasonic messages not only with their large, sensitive ears, but also through their very feet. Beneath the thick pads of an elephant's foot lies a network of highly sensitive receptors that can detect the faintest ground vibrations. As infrasound waves travel through the earth, they create subtle vibrations that elephants can sense through these specialized receptors. Imagine standing barefoot on a wooden floor as someone walks heavily upstairs. You can feel the vibrations traveling through the floorboards and up your legs. Elephants experience something similar with infrasound. Their large padded feet act like giant contact microphones, picking up the low-frequency vibrations generated by distant elephant calls. These vibrations travel up their legs and are transmitted to the inner ear, where they are processed alongside airborne sound waves. The key to this remarkable ability lies in specialized sensory receptors called Pacinian corpuscles. These tiny yet incredibly sophisticated structures are the unsung heroes of the animal kingdom, playing a crucial role in how elephants interact with their environment. These small onion-shaped structures are found not only in elephant feet, but also in the skin and joints of many mammals, including humans. In elephants, however, they are particularly abundant and finely tuned to detect the faintest of vibrations. Pacinian corpuscles are particularly sensitive to pressure and vibration, acting like miniature accelerometers that detect changes in pressure and movement. Imagine having a built-in system that can sense the slightest tremors in the ground, providing a constant stream of information about the world around you. When an infrasound wave travels through the ground and encounters an elephant's foot, it causes a slight deformation in the footpad. This is where the magic happens. The deformation, though minuscule, is enough to activate the Pacinian corpuscles. This deformation stimulates the Pacinian corpuscles, triggering a nerve impulse that travels to the brain. It's a highly efficient system capable of transmitting information almost instantaneously. The elephant's brain then interprets these signals, allowing it to hear the infrasound through its feet. This ability is not just a fascinating quirk of nature, it has real-world implications for how elephants communicate and navigate their environment. This remarkable adaptation allows elephants to perceive a much wider range of sounds than they could with their ears alone, opening up a whole new dimension of sensory information. Through this advanced sensory system, elephants can detect distant thunderstorms, locate other herds, and even sense potential threats. It's a testament to the incredible adaptability and complexity of these magnificent creatures. Understanding the role of Pacinian corpuscles in elephants not only sheds light on their unique abilities, but also underscores the importance of preserving their natural habitats. These sensory organs are finely tuned to the specific conditions of their environment, and any disruption could have significant impacts on their well-being. So the next time you see an elephant, remember that beneath their massive exterior lies a world of tiny, intricate structures working tirelessly to help them survive and thrive. The Pacinian corpuscles may be small, but their impact is undeniably huge.